Hey there and welcome. Today we are going to solve and graph compound inequalities. Let's go ahead and get started. All right, the first thing that we need to do is talk about what a compound inequality even is. Now, a compound inequality is the comparison of two separate inequalities on the same graph. We show this in two different ways. We have one that's called union, which means or, and most of the time that graph is going to look something like where we have something that's bigger than this value or something smaller than this value. And so it's showing us the two different possible places where all of the values that you use for your variable are going to give you true statements. So this is saying that that section in the middle, that is the only place where our statements are not going to be true. So it's bigger than this or it's smaller than this. The other one is called and it really just means common. What is the area that is common between the two? And so for this graph, it's going to kind of look a little bit different. We might have that here it's less than or equal to, but then over here it's greater than or equal to, or just greater than. But we don't draw the graph like that because it's the part that's common. And the only part that's common is between these two spaces. So instead what that graph ends up looking like is maybe we have an open circle here, a closed circle here, and it's just that space in between. So it's all of the values of whatever your variable is, x, y, z. Ooh, I lost part of my letters. All of the values of x or y or z or whatever your variable is between this value and this value. Anything between these two values will be true. And that's really what the difference is. And you're going to notice these funky little symbols that we have going on here. And those really just mean union and, but you'll see them mostly in higher education classes. So we don't use them so much right now, but we're exposing you to them. So let's actually look at an example. With this example, we need to look at whether or not it's an and or an or, a union or an and. And the easiest way to do that is to figure out if the word or is in here. So I look at this and I don't see the word or anywhere, which means that it is going to be an and. It's common. Now there's two ways that you can show your work for this, because in reality it looks a little confusing. You can take the first part and set that up. So we would have negative 36 is less than 3p minus 6 and solve that like a two-step equation. And then you can take the second part where we have 3p minus 6 is less than negative 15. And you can solve those separately. Absolutely you can. And we can do that way real quick. We're going to add 6 to both sides for both of these. Those 6's are going to eliminate. Negative 36 plus positive 6 is negative 30, less than 3p, and we have 3p is less than 9. And then we divide everything by 3. And negative 30 divided by 3 is negative 10, is less than p, and p is less than 3. We can absolutely do this way, and then our final answer will be written as negative 10 is less than p is less than 3, which says that p is in between the values of negative 10 and 3. So when we go to graph it, here we have our negative 10, here we have our positive 3. These are both open circles, and p is the space in between the two, so we would shade in between the two. That is absolutely one way that you can choose to solve it. The other way is to actually just leave it how it is. So we have negative 36 is less than 3p minus 6, which is less than negative 15. And just do all of those steps to all three parts. So if I add 6 here, I have to add 6 here and over here. And I still end up with negative 30 is less than 3p is less than 9. And then we divide all three parts by 3 because that is what is with our variable. And we end up with negative 10 is less than p is less than 3. You still get the same exact answer either way, Both ways are completely valid. It's personal preference. It's what you choose. So let's look at another one. All right, so again, with this one, we need to figure out if it's an and or if it's an or. This one actually says the word or, so it's an or, which means that it's also union, right? And so that just means that it's going to go in two different directions. So we're going to solve these as two completely separate inequalities. So you have 2n plus 7 is greater than or equal to 27, and 3 plus 3n is less than or equal to 30. So let's solve these. I'm going to subtract 7 from both sides on this first one. So I end up with 2n is greater than or equal to 20. And then I'm going to divide both sides by 2. So I got that n is greater than or equal to 10. Or that second one, I'm going to subtract 3 from both sides. So I have 3n is less than or equal to 27. Then I'm going to divide both sides by 3, so I end up with n is less than or equal to 9. So now that I go to graph this, I have a value point at 9, and I have one at 10. I'm going to write the smaller number first because it's smaller. And it's a closed circle. Remember, when we have that inequality with the line underneath, that's a closed circle. That point is included. And it's all the values of n that are less than 9, smaller than 9, going in the smaller direction of 9, to the left. And then we have that n is greater than or equal to 10. Again, that line gives us equality, which means that it's a closed circle. And I'm going to shade where the values of n would be bigger than 10, which happens to go that way. So here is the written out answer, and then here is our graph to support said answer. So that means that I can take any number that is smaller than 9, plug that in for both, or I can take any value bigger than 10, plug that in for both, and they would give us true statements. All right, so now let's look at an actual graph and create the equation for it. Create the statement. First, we have to determine if it's a union or an and. And because it's going in two opposite directions, we are going to say that it is a union. So now I'm going to look at this part over here, and whatever it's going to be an open circle, so it's not going to have the line underneath. And I can see that it is less than. It's heading where the numbers are getting smaller. Remember that the bigger the negative number is, the smaller it actually ends up being. So even though it's saying 12 and 14, they're negatives, so they're small. So whatever it is, it's going to be less than a number. Now, I don't care what variable you choose. You can choose x, y, z, q, fish, potato. That's completely your choice. I'm just going to use good old-fashioned x. So x is less than whatever this value is. This value happens to be at negative 11, so I'm going to write negative 11. Or, right, because we said it was union, and union means or. Again, here I've got an open circle, but this time it's greater than. We have to use the same variable. So, or x is greater than negative 4. And that's going to be our answer, right? So if we're given the graph and we're asked to actually create the scenario, this is all that it's looking for. Let's look at another one. All right, so this one here. This one is going to be an and. It's the space in between. It's that commonality. So we are always going to start with the smaller number, which is right here, and we are going to end with the larger number. And our variable always goes in the middle. So my variable goes in the middle. We always start with the smallest number, which here happens to be negative 9. And it's a closed circle, which means it's going to have that equal underneath. And when we write our ands, it's always going to be less than or equal to, always. For both, right? Again, our higher number is also a closed circle, so it's also going to have that or equal to, and then this time it's a positive 9. So our answer goes between negative 9 and positive 9. So x is between negative 9 and positive 9. And that's it. Remember that inequalities give us an infinite number of answers. So even though there's only this many actual whole numbers and integers in here, you can't forget all of the little decimal points in between. Infinite number of answers that inequalities give us, and that's why we use that shading. So that's it for today. We discussed compound inequalities, the differences, and how to solve them. So until next time, I'll see you later. Love you, bye.